Our next speaker is Eduardo Castello. He's a postdoctoral fellow at MIT Media Lab. He did his PhD in robotics at Osaka University and his bachelor's at Portsmouth in the UK. Eduardo is interested in building distributed robotic systems that can change the way people feed, communicate, transport, and live. Please reserve your questions till the end of the talk. Thank you.
Thank you, Sergey, for a nice introduction. Thank you, everybody, for being here. So yeah, I have to say before we start the talk that I am going to go I'm going to zoom out a little bit, I'm going to give a pretty general view of a new field. I'm not going to introduce a paper here. I'm going to introduce a new field of research that we are trying to explore in the Media Lab, and we coined it trustable autonomy. There's also people that calls it verifiable autonomy. But yeah, basically what I'm going to present in the next slides is the combination of two things that apparently don't do much with each other, but together they do something interesting, right? So I am not a super blockchain expert. I am not a cryptographer. I'm a roboticist, as Sergey said. So bear with me, right? Let's start. So, during the last maybe 10 years, yeah, we've seen this massive hype of robotics, of AI in the media, in academia, etc. Right? So there's different types of people here. No, there's people that says that robots and AIs are going to take over the world. The Terminator is coming, right? And this is the beginning of our end, right? But also there's other people that says that this rise of automation can be really, really important, yeah, to provide a new type of human, right? No, not a human that is consumed by technology, but a human that is extended by technology, right? So of course it's a very complicated topic, right? And there is no way to understand right now what is going to be the main outcome of this. But I would like to zoom in a little bit, to simplify the things, right? And start with something that it was really important for me. I don't know if you know what this device is, yeah, but this device is called Safecast, and it became really important in the after hours of the Fukushima accident in Japan. So I was there. I was doing my PhD in Japan back then, and when the Fukushima accident happened, really we didn't know what was going on. So the foreign media was saying that the Armageddon was coming. Even embassies, foreign nationals were escaping from the country because they didn't know what was going on. But the Japanese media was saying that everything was under control and everything was okay and there was no problem, etc. Right? So many people, including me, back then we didn't know who to trust. Right? We didn't know if the Japanese media was correct or if it was the foreign media who was having a better grasp of the situation. But back then, a lot of people feeling that they couldn't trust the normal channels of information, they decided to do something, and then they decided to put a Geiger counter, right, with a GPS system, and make it an open source, open hardware project called Safecast. And through putting this mini device, kind of a Raspberry-sized small device, put it outside their homes, put it in boats, in drones, in their cars, etc., with the possibility of doing measurements of the radiation of their point, yeah, of interest, and uploading this information to the internet. So these kind of interactive maps that could be generated. With the information not of the individual but the crowd, people were able to be informed about what was the real situation of the neighborhood, the city, etc. Right? So in a sense, when trust was not possible through the normal means, it was a society who organized in order to build trust from the crowd, right? But this thing that inspired me a little bit during my last years of PhD also has a context, right? So during 8 years in my life, first for master's, then for PhD, I was working for one of these two guys here. So this one of these guys was my professor, my sensei, and the other was his robotic clone, right? He's Geminoid, creepy, right? The interesting thing like about this is that like my professor, Professor Ishiguro, was very interested in the fact of how robots could be an extension of us, and sometimes could be a substitute of us, right? He was very interested in something that we all have thought at some point in time in our lives, which is how can I be in two places at the same time, right? He solved it in this way. Actually, for a time, he didn't want like to be in thesis committees, like in thesis defenses, like in lectures. For example, he was living in Osaka and he didn't want to go to Tokyo because like it was like really troublesome for him or something. So he just sent his clone to that like part of the world, right? And then he Skyped in through him in order like to give like these talks, right? And me and another graduate students were the ones like moving this like a robot like all around the world. The thing is that, well, you can see this like this robot in action. Now they are two at the same place, so it's not this kind of like teleoperation thing that I talked about, but you can see that it's like very very realistic, right? Well, when I started my PhD with Professor Ishiguro, I realized that this was his future of robotics, right? The fact that you have one robot that is very complex, that is very expensive, that somehow extends you, right? But I realized that that was not my vision of the world of robotics, right? I didn't believe in this one very expensive robot near you, right? What I believed in was something more like this. In here, instead of seeing one very expensive robot, what we can see is a lot of very, very, very simple robots around us, yeah, which actually, through cooperation and collaboration, they can do way more complex things than the individual, right? So this is like an experiment that I took like in the last year of like of my PhD. So what you are seeing here is like a mini swarm of robots doing something called foraging, which is something that all animals do. They are trying to balance a trade-off between exploration and exploitation in order to do a task, right? In this case, is finding these 3D printed tokens and putting into this nest, kind of like ants do, right? The interesting thing about this is that when robots take these like tokens and they put it into this like nest, the nest gives them like a reward, yeah, in the shape of like a battery recharge. So robots that are very good at finding the resources can keep on doing that, while the robots that are not so good or can basically be like in the nest keeping energy or being in bypass mode, right? So the interesting thing about this is that we were able like to keep systems for a really long time operating. So if you take out these 3D printed tokens and you put passengers in a city and you put like an airport where the nest is, you can see that this has like more sense, right? Or for example, robots finding resources in where humans cannot operate, for example, under the seabed or outer space, etc., right? But I finished my PhD and then I realized that I could take inspiration from other societies where the individual was cooperating and collaborating with their peers in order to do something beyond himself or herself, right? Which actually were human societies. So I came to MIT, I came to the Media Lab, and then I started to explore what worked in human societies in order to export it or put it into robot societies, right? But this has a problem. Yeah, the problem is that if you increase the number of devices, if you increase the number of robots, and by the way, for me, like a robot is any computer that has the physical ability to interact with the world. So basically, a robot could be almost anything. Could be a self-driving car, but could be like a phone, could be like a smart home, could be whatever. So you don't have like to imagine like wheels and arms, but a more pervasive like thing. This has a problem, right? When we have robots all around us and then they are communicating in this distributed way, the complexity of this network also increases, right? Increases as the number of devices increases. And even if we put different types of devices, my home like talks to my car talks to my Roomba talks to the government talks to whatever, the complexity of this increases exponentially, right? Up to a certain point in which like our human capacity to understand what's going on around us cannot cope. So it would be fantastic that in the world of tomorrow, in which we are going to leave a big part of our lives to automation, to machines, to algorithms, right? We are able like to achieve something like the green line, right? In which we let them organize, have like peer-to-peer communications, take the part of our lives that we don't want to take anymore, but at the same time, don't give up the possibility to understand what's going on in that network, to understand them, right? And for that, we need something called trust, yeah? And And trust is a picky thing. Like, for example, the speaker at the beginning of this session was like saying that, yeah, trust is a very picky thing, and especially like into this blockchain context, right? While in the analog world, we are we can be almost sure that this is like a USB key, and this is like a computer, and this is like a speaker, right? In the digital world, this is not so easy, right? This is mainly because the internet, the tool that we are using all the time and paradigm of this digital age, was not designed to generate trust. It was designed to move information efficiently and robustly from point A to point B, but not generate trust. So how we are going to solve this, right? One of the things that I think is interesting is something called the blockchain. And I say the blockchain, not the blockchain, because I am not like a person that thinks the blockchain is the solution to every single problem that humanity has. I am sure that many of you don't believe that either, right? And I wanted like to comment on something that like one of the questioners like said. We are living in a world of hype, right? Like blockchain is like a buzzword. It's everything and nothing at the same time. And I think mainly it's because like some of the companies like that are really interested in this field these days cannot cope with the fact that they lost the next internet, right? So even though it doesn't make sense like to invest many of their money in things like the blockchain for certain problems that could be solved certain other ways, they just want to push forward because they cannot be out of the next big thing, right? And this creates a lot of problems like for academics and researchers because we have to justify up to the possible extent, why we do what we do, right? And why we explore what we explore. Well, as you may know, the big interest and the big breakthrough of this concept called the blockchain is the fact that now we can distribute the trust. Now we pass from a centralized paradigm of trust, yeah, from a man that needs to vouch for things, yeah, like the central banks, like governments, etc., to the fact that if 10,000 people that do not see each other and do not have anything to do with each other agree on something, maybe that something happened, right? So I will skip this, but in a way, what we are trying to explore these days is what happens when you have a history book of transactions among certain peers, right? And what I'm going to propose in the next slides is what happens when this history book is not only about humans transacting, but about robots. What happens when robots, a group of robots, have a transactional book that explains their history as a group, as a network? So the first project that I would like to introduce relies on a trade-off that we all have seen in these days. We are facing a war in the field of data, right? We are trying to balance a trade-off between data, for example, security and data utility. We all have seen how, for example, data is very important. Some say that data is the new oil, right? We researchers think that for the right data with the right person at the right time could change many, many things. Imagine how beneficial would be that all medical records will be in hands of cancer researchers. How boosted the cancer research will be able to move forward. But also we understand that all these same records, this information that could be publicly available for these researchers that could be out there, could be super harmful if insurance companies will access to this information. So we are trying to balance this trade-off between data utility and data security, and this is something we need to solve in these years, right? So this, what you can see here, is a specific problem within this trade-off. What you're seeing here is a pair of robots called Now. These robots are very well used for human-robot interaction. And the little fellow that you see in the middle is a guy with autism. Yeah, it's a kid with autism. In the Media Lab, we have a lab called Affective Computing. They are very, very well known for conducting research and exploring technologies that could increase the well-being of people. And one of the research lines is autism. Yeah, how we develop robotics and technology to interface with autistic kids, right? You know that kids with autism love robots. And this is because robots are more predictable than other agents, right? So the people that were conducting this research normally program these Now robots in order to do a storytelling with the kid. So the kid was listening to the robot, and the robot, for example, was saying, well, I'm going to tell you this story, and in this story there's this character which is super happy, and then the robot does like a gesture, right? So the kid knows, oh, that's what happy means, right? Or the character suffer like something, and the character is sad, so the robot could say, oh yeah. So the kid could say, yeah, this is what sadness means, right? The researchers for this project realized that every time that they had to conduct a therapy with a kid, the kid was kind of like a blank sheet. The robot had to learn from scratch from that kid, right? The robot didn't have any context about the kid. The problem is that the researchers couldn't access to information about the kid, couldn't understand what the kid was coming from, so they could personalize what was going on in the robot. And this is mainly because, like right now, like a kid with autism, like looks like this in the world of internet, right, and the digital space. So doctors have information about these kids, and they put it into databases in hospitals. Educators do the same, and public institutions do the same. And by law, these databases cannot talk to each other. So what we did in this project is providing like a proxy to these databases, in which we weren't able to see the raw data, so we could copy it, distribute it, whatever, but we were able to ask questions to the data. Yeah, we were able to send an algorithm to the data instead of sending the data to the algorithm, and say, well, I don't want to see your raw data, but please, can you answer this question about whatever you have there? And then in exchange, get aggregated information. 85% of the kids from 5 to 7 react bad to this treatment, for example, right? So we created like a model in which the robot was conducting the therapy locally, having video and audio feed, and at the same time, whenever it needed to personalize this activity, just send a query to this proxy, and the proxy distributed it to these databases and got aggregated information back. The interesting thing, for the blockchain people in the audience, is the fact that that question and that answer was able to be logged, was able to be verified, and was able to be included in a transaction in a public blockchain. So at some point in time, somebody that was, for example, the legal guardian of the kid or the people from the hospital, etc., could go to the blockchain and say, I want to audit that robot. I want to audit that interface. I want to know what the robot took into account in order to take the decisions that they took. So it's the first time that we are able to account a robot, right? Well, the interesting part of this is that we also did some machine learning that I will show you in the next slides, and how this operates with networks of robots, right? So what we are seeing here is what happens when you don't have only one robot, but you have many robots in a network, right? So this paradigm is called federated learning. Some people call it now split learning. But what happened here is that robots in the edge of the network are able to get expertise on treating certain patients and certain types of autism. And now they are able to share their model, their expertise, instead of the data that created that model. So in other words, what we did is if the robot at the bottom conducted 1,000 therapies and became really, really expert in detecting some type of autism, now if you open a hospital and you plug it into this network and you have a completely blank robot, you are able to go and say, hey, robot with expertise 1,000, could you give me your model about this? I don't want to see your data. I don't want to see how you got this model, but please, can you share me this model? In other words, what happens when you are able to do the model, so bring the model to the data instead of the data to the model, right? So we iterating the model and being able to move it along the network, we are able to get a better performance, right? But this presentation is not for that. So if you are really interested in the details of this, please come after the presentation and talk to me. Happy to give you all the details about this. But yeah, but you will tell me now, okay, Eduardo, this is fantastic, this is very cool, but but yeah, does this work in real life? And is this so nice? Well, this works as long as we are all okay, right? I told you at the beginning of this presentation that I took inspiration from human societies in order to put it into robot societies, right? But in human societies, not everybody is fair. People lie, right? There's corruption, right? So what happens when this happens in robot societies? Robots might get hacked, right? And robots might want to deceive their peers, for certain reasons, right? So there is a lot of controversy these days about what happens when you hack these machines, you hack a self-driving car, for example, right? When you hack like a robot that has your data, or you hack Alexa, right? So imagine that, no? Imagine the fact that like you get like a ransomware, no? Like, and the ransomware like gets into your phone and you cannot see your contact list, but also the ransomware goes to your self-driving car, and if you don't pay $3,000 like dollars in Bitcoin, the car is not going to break, right? So, which actually it seems that it's not so far away. So what happens like with all these like distributed like networks like of robots when there's like bad actors? Is blockchain able like to solve these kind of things? Is useful? No. Well, actually, these problems are not future, are present. Maybe you know this example. This is like a robot called Tug. Tug is like a robot designed like for doing like certain tasks in care centers and in hospitals, deliver like drugs, patient records, etc. And the designers of this system thought that because it was intended like to be used in a swarmish like perspective, right? You have like many robots doing like moving along the hospital. The system was kind of like fault tolerant and robust. If like one robot like falls or breaks, the other robots will take over the job and will be able to cope. But what they didn't understand is what happens not when robots fail, but robots are hacked in order like to deceive like the others. Well, it is proven that if you have like a distributed robotic system such as like this, or like a swarm of drones, and you hack one of the members in a certain way to poison the communications, eventually the whole swarm will collapse. So imagine that. You have like a swarm of like robots like delivering like packages in a city, you hack one, one like poisons the communications in a certain way to the others, and the whole swarm collapses. This is not what these researchers say in their abstract and in the introductions of their papers, right? Well, it seems that it's like that. So what we did in the Media Lab was trying to say, okay, so can blockchain and this technology help into this like with these problems? And what you're seeing here is like a problem that is very, very simple, right? It's like a consensus problem in which like robots, which are like these like little like green like dots like in this like checkerboard, are moving, and they are trying to consensuate which is the majority color like, in this like floor, right? This is like one of the typical problems like in this space. So the robots are super simple. They can only sense these tiles, and at some point in time share their opinions and say, hey, I've been 20 minutes over there, and like I checked that there is like 40-60. What do you think? Ah, no, I've been over there and it's like 30-70. Okay, so they concentrate like their opinions, and then at some point in time, through exchanging their opinions to the whole swarm, they come to a conclusion. Black is the majority color, white is the majority color, right? Well, so what we did here is that we increased the difficulty. So like it's not as easy to get this problem like solved if like if you have 80-20 than if you have like a 49-51, right? So, and then we contrasted like two things, yeah? Like we contrasted the state of the art, like which we call classical approach with no blockchain like in the attached, and a blockchain like approach in which like the robots vote and share their opinions through transactions into this like private blockchain. At some point in time, the blockchain gets synchronized, right? Well, so what we see here is like the early results. So in the upper part, we see the three algorithms of the classical approach. And like what you see in the x-axis is the difficulty, right? So as I said, like maybe like in the beginning you have like a 90-10, then 80-20, then 70-30, etc. And then like in the y-axis you have like the success probability. So the probability that the robots came to the conclusion, to the right conclusion. Black is the majority color, or white is the majority color, yeah? And this represents the reality. Well, what you see basically is that the results like of like the classical approach and the blockchain, which is in the bottom part, do not differ so much, right? So the success probabilities are more or less the same, and yeah, everything looks like pretty similar. Of course, counting with the fact that the blockchain approach has a lot of limitations, right? Who stores all these like data in these simple robots, like bloat, like computational complexity, etc., right? But what happens? So from this slide, we will say that like it's not very justified the fact that you put like a blockchain like there, right? But what happens when there's malicious robots? There's robots like programmed like to deceive the other robots, and then we encapsulate it like in these like malicious robots, like sensor errors, lost communications, message tampers, etc. Right? What happens then? Well, we conducted the same experiment, but including like malicious robots. And what the experiment like goes is that like robots are connected to an auxiliary like a Ethereum node. There's like a mine of a contract, which basically is the constitution of the robots. What happens, how votes gets exchanged, where are stored, but also what happens like when we found that you deceived like the other robots. It's a little bit like a constitution, as I said. So robots register to the smart contract, and then the smart contract like publishes and subscribes like information, and then the consensus like starts, right? Well, so what we saw here is that we compared like the classical approach with the blockchain approach, and then we, instead of like difficulty, we fixed the difficulty, and like in the x-axis you see the number of Byzantine robots. So what we see is that in the classical approach, as we increase the number of like Byzantine robots, the consensus like drops dramatically or even cannot happen. Yeah. So imagine like a swarm of like 30 members, like for example, right? 3 nodes get hacked, the probability drops like to 0.1. Pretty crazy. But in the blockchain approach, we see that we are able like to maintain like the results. And this is basically because of like the property of the blockchain, one of the few properties of the blockchain that are interesting like to store, which is the fact that we can find inconsistencies in the ledger. We can exploit the general's problem into a way in which we can find inconsistencies. For example, if I'm the robot number 59, if I'm the robot number 59, and then I told you that white is the majority color, and we share the same controller, and 1 minute afterwards, I went to you and I said, black is the majority color, and we store these votes into the blockchain, at some point in time, we are able to understand that there's a problem with me. I changed my opinion in a way that is very weird that happened like that way, right? So with this, we can flag these operations and we can encapsulate these inconsistencies into a reputation system, for example, or in a way in which we can exclude these robots like from the general consensus, and therefore we can keep the activities of the system even though there's malicious actors, right? So this is like the time convergence, but it tells the same story. So with this, I would like to pick your curiosity a little bit and like try like to provoke you about what happens when you have like a system in which you can trust like these robots, or these robots could be trustworthy, right? Or could be verified in a certain way. So what we think in the Media Lab, we are conducting like some like projects in order like to extend this idea and project this idea in a way in which we say, well, if this system is possible, maybe the robots will be so autonomous that they will be able to advertise themselves like for their work, right? So what you see here is what happens when robots have like Facebook accounts, right, and Facebook pages, and they could be found like in social media in order to conduct like a job, for example. This project is like a starting like a project that we have in which, for example, we found the people at MIT with great difficulty right now like to conduct research in places like Antarctica, yeah, for climate change purposes, right? But we found out that there's like already NGOs and other like institutions there with robots that are used more or less like 15% or 20%. So 80% of the time of the robot is not doing anything. So we realized that through systems like this, we can make the robot work and be on demand for other people. And then the output of the robot, which is basically the data, something that we talked about like before, could be encapsulated, could be timestamped, and could be not shared into the blockchain, but maybe could be an acknowledgement of that operation, could be like sent into the blockchain, attestation of that. And then you could basically connect researchers like in spaces which don't have like the resources to conduct this like research, and hardware that is already in place. Yeah. If you want to know more about this project, let me know. So we developed like a sensing as a service model, or a robotics on demand, in which robots are able like to federate like into big like teams, like given like their sensors and given their hardware capabilities. Yeah. So you have like swarms with different operabilities. Or capabilities, and then like people could request like services like from these swarms based on these capabilities, and like the robot could do their job, and then at some point in time get the output of this job into like a blockchain like instance, right? So what we are trying like to propose is the fact that since during these days access to information is more important than ownership, right? We can create like networks like of data in which like robots are present there, and you are able like to access like to these networks. But of course, you need like some way of like verify that this information is correct, and this information comes like from really repeated like sources, right? And this is basically what we are exploring like these days. So yeah, this is like a projection of like something that we are living like today. As you may know, like Uber's own no cars, Airbnb owns no real estate, and Facebook generates no content whatsoever. And this is because the paradigm has changed. Right now, access is more important than ownership, and what we are trying like to do is like put some context like to this access, maybe through helping from like blockchain technology. And what I explained you like in this like presentation is a little bit not like a particular research. We have many different like research within this big umbrella, but like the race of a new field, which we are trying like to mix three things that are very important like these days, I believe. One is like robotics and automation. Robots are here not to consume us, but to extend us, right? And they are here to stay. But the other like field is like digital trust. Now, like we have like tools like to understand like these like processes like better, right? And understand how to verify like a machine and how to understand like digital trust. And of course, like this will be completely useless if we don't put this into a context, right? And the context is not like making like another like a hyperledger, but like making like a society like greener, like more like informed and like and better, right? And what we are trying like to do here is basically put all these bubbles together, explore what's in the middle, and try to deploy it, right? As far as we can. So I am really happy like to say that like this field we already got like symposium like in the Media Lab like about who is thinking like about this field. So I completely invite you if you are like in somewhere in this space. I totally invite you like to send your papers like to the next edition that is going to be in December. The first edition was very successful. We had like great speakers like Sandy Pendland, Nihar Arura from DCI, etc. So yeah. Happy to receive any ideas or any comments, or if you want to help, more than happy like, to talk to you. And yeah, I would like to finish like this presentation with the first slide that I had, right? I think that I kind of like convince you that this is not like about us versus the machines. It's us with the machines, but we need to put certain things in place, and these things in place will be really important to explore this combination together in a culpable way. And yeah, let's with this I want to like finish like this presentation. Thank you very much. If you have any questions, more than happy to receive them. Mm-hmm. Mm-hmm. Yeah. Yeah. So the question is like, what happens when we are part of the machine, right? We are cyborgs, right? And what happens with our cognitive limit, right? To understand what's going on. Yes. So in the Media Lab, we are conducting a lot of like research about what happens with this like a human to machine symbiosis, right? And what happens with the fact that actually we get extended by these machines. There's like a lot of controversy like about that. There's a lot of ethical like issues like going on like with these things. But one of the things that like we are trying like to explore here is what happens not when we have like one single entity as a machine, right, and one single entity as human, but we have many different ones, right? So our society, I'm really interested in the fact that the society is getting more and more complex, right? And we need to have like some way to understand this complexity and account for this complexity. So I think that certain tools within this blockchain space are interesting to understand this complexity, right? I don't know if like for example in the world of like a human robot interaction or cyborgs or whatever, blockchain has a space maybe like to understand that, for example, like a part was constructed in the way that was supposed to be constructed, or that comes like from the right vendor or something like that. But I think that the work explained here goes more in what happens when we have many robots like around us, right? That are doing many things at first. How do I come to that complexity, right? And the way of, and this is connected like to the cognitive limit. For example, this is like something very studied in for example, for DARPA and like the military, right? The fact that one operator, how many robots one operator can can operate, right? For example, if you have one robot, right, you operate the robot and all your attention is focused to one robot, right? If you have like two robots, basically you have like to split, right? They're like X, no? If the robots are different, if they have different capabilities, you even are more puzzled, right? Because now you have like to focus at the right time at the right robot. So at some point in time, if this increases or scales, right, your cognitive ability to understand what's going on there and operate is surpassed, right? That's why we need like to add some automation, some intelligence, like to these things in order to reduce the amount of like, time and focus we spend on this. The problem is that if we start like to increase this autonomy raw, barely back with any way like to account for it, to verify it, we will get into a very different problem, which is like we gave them so much autonomy that now we don't understand them. We don't know like when they share the data, with who they share the data. And we need a way to account that. We need a middleware like to account for that. So that's why like we are trying to explore what we are trying to explore. Yes. Mm-hmm. 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 Okay, let me start with the second one, okay? Yes, that's completely true. Nobody can assure you that like some data was like originated in the way that you think of the robot, like told you, if there's no verifier, like for that. So that's why what like we are trying like to do is add new methods in which like the robots have to prove that they are in a certain space in which they can sense like a certain thing, right? Or they did like something before in order like to be able like to say what they're supposed like to say. We are trying like to explore like a situation in which like robots verify that work has been done in order like to, for example, reward. There's like a lot of like there's a big field of like game theory, like an mechanism incentives, like no market design is called, in which basically you like create like certain incentives like for the robot not to lie. There's a way in which like you have like you can have like an upper layer and say, well, maybe lie costs money for the robots, and you can incentivize this into the system. This is work on progress that we are doing. So there's ways like to manage these kind of like things. And the first question, yes. So what we are our assumption is basically the fact that like if like you have like a group of robots which scales, right, and the robots are homogeneous, right, the attention span that you will need like to treat like for each single robot will basically be linear, right? More robots, more attention span, right? Because all robots are homogeneous. But when you start like to get like heterogeneous robots, like so, which are different, and ones have like a different actuation power, and ones have like a different sensor power, right? Maybe the attention span, the complexity of like this system, the amount of information that you need in order to describe the system and their interactions will grow exponentially. I can give you like the papers for that. Yes. Mm-hmm. So I don't know if I understand the question correctly, but is how does the blockchain play into this system in order like to don't let the robots go rogue? That's Mm-hmm. Yeah, so like the point of this like a project was like how like to improve like a deep learning model um, as a network in a way in which you don't expose the local data of each single like a node, right? Because this is like very like private like information. So what we did here is develop like this model in which you can have like this secured like like data sharing, right? But also how do you account for all these like transactions, right? And how you like can decide on which is the next model like to build upon, right? Which is basically how do you build like a Git like a repo out of like this, right? And who branches like the model and who basically gets like the last version of the model and who constructs and who validates like the model, right? So we decided that like we build like a consensus like mechanism like here, which are not in the slides, and then what we did is like we put like an attestation of when the robots like get into an agreement, and then we put it like this attestation into a like a public blockchain. This is like a private blockchain. There's like a public blockchain in which like they notify that they reach an agreement or the next like model is version 2.5, right? So with that, if you include like a robot, if you're a hospital, for example, and you include your new robot, and at some point in time you put some of your data like into the process, you are able like to understand that the decision within the network, for example, we all agreed that this is the next model, and you didn't contribute like to this model, for example, your data is not taken into account, right? Is actually like the final step of like the process. Like so, you can go to the public blockchain and say, whatever I saw in my private like blockchain resembles what I see in the public blockchain in this attestation. Yes, okay. So things are okay. Nobody lied to me. I don't have like I haven't been part of a cyber attack or like a man-in-the-middle attack or something like that, right? So we're trying like to use this like private like a network and the public like a capability to attestate what happens as a group in order like to see that individual parts of the network haven't been deceived or have not been tampered, right? So you as a user of these networks or as a guy that wants to put some resources into the network can understand that things didn't go bad, no? In a certain sense. Yes. So for now, what we are exploring is just like a middleware. We are having like a layer in which we are putting like these capabilities, and the robots are doing whatever they are supposed like to do. So there's no different OS like in the robots, but the only thing that they are doing now is the fact that if I'm robot number 15 and you're robot number 59, right? At some point in time, like I say, well, if you give me some information, now I ask you prove it. Prove that you have this information. Merkle trees are like a great way like to do this kind of stuff. So, and this is basically like a new layer within our autonomy that represents like a way to understand this interaction, right? But it's not something fundamentally different like from always. Yeah, great.